Okay, good afternoon, guys. Today we are launching one of our very important products, which we have designed and we're placing into the market. Okay, it's a pen test machine. Okay, I'm usually former certified welding inspector, welding engineer, and inspector. And in so many issues in the country, okay, to promote the industry in Cameroon. Okay, the pen test machine is a special machine, okay, which we design, okay, and manufactured, okay, to the different codes, okay, that are managed, okay, when it comes to fabrication, manufacturing, okay, that is aspect section 9, 8.1.1, okay. Why the pen test machine? Let's understand this. Okay, welding is an art, okay, blended in science and engineering, okay, and technology. Which means during the welding process, what happens is the welder is making use of science, engineering, technology. The weld is a permanent qualiescence, okay, some quantity, okay, that is deposited across two members. Okay, to hold two joints together. Okay, but the joint must have the desirable mechanical, the desirable mechanical properties that are expected of that joint, okay, to support the service loads. And these mechanical properties that are expected in the base metal are dependent on the microstructures. Get this very well, guys. Microstructures that are left in the weld metal of the wood. So we established a welding procedure specifically to enable us have the practical steps which we're supposed to follow. That is, the welder follows in the welding of a test piece or maybe a production weld, so that the deposited weld metal is going to have the desirable mechanical properties that are expected of it to be able to support the service loads. Okay, so procedures are expected to be qualified, which means we must be sure that the deposited weld metal has the desirable mechanical properties, okay, that will support those service loads. That is why we qualify the procedure. Okay, we have the test samples that are welded procedure that is established by the engineer. Okay, and then we do verification, okay, of the deposited weld metal, okay, using inspection, okay, which proceeds with visual inspection. And we have to proceed to mechanical testing, okay, after non-destructive testing. That is procedure qualification. So we are talking about the pen test machine, new product which we are placing, which we design, manufacture, and placing in the industry. The pen test machine constitutes part of the welder qualification process. During the welder performance test, okay, what are we targeting? What are we targeting? What are we targeting? We want that the welder should be able to deposit a sound weld, okay, following a welding procedure specification, which, if verified, okay, maybe through the inspection methods that are available, okay, it should meet the design specification. That is the code standard that is demanding the construction job. Maybe it can be 9, it can be 8.1.1, or maybe API 6, maybe API 1104. So these welders are qualified in different codes. Okay, so in the process of welder qualification, we make use of the bend test machine. And why the bend test machine, or the importance of the bend test machine? We have acknowledged the fact that, okay, the welding process, to establish a weld, we require a procedure. That procedure is well established beforehand, and the welder is expected to follow that procedure and execute the execution of work. So this procedure enables us to be sure that the deposited weld metal is going to have the desirable mechanical properties that are expected of it to support the service goals. So, if a welder is ignorant about or cannot comply to the welding procedure, that is already a problem. The welder must understand that there is interface temperature that's required. I respect interface temperature. Understand that maybe the heat input is required for that joint, because the welding process will make use of heat. This heat raises the temperature of the base metal from low temperature to high temperature and causes the fusion, and solidification. And you have the permanent quality, which is the word deposit across the joint. You see there? So we are saying that the welder must be cognizant of all of this, so as to be able to carry on a good work. Okay, that's going to have the properties that we expect of it. So, what are we seeing here? We are saying that a welder who does not follow the welding procedure is a problem. We can have a weld that is welded. Okay, look at it, it's good shiny, but that is a bad weld. Okay, because of maybe insufficient heat input or excessive heat input. Okay, so we are saying that the use of the welding procedure specification or execution of welding procedure specification is primordial for the quality of the weld. Okay, because in that case, you have the desired amount of heat input, the control amount of heat input that is fully established, okay, and calculated, that is supposed to be executed by the welder during the welding process. So using maybe the electrical parameters. Consequently, the welder is supposed to be cognizant of this. Okay, knowing that I'm going to use these electrical parameters. Okay, my interface is supposed to be this amount. Okay, this temperature maybe 100 degrees, this maybe 100 degrees. Okay, and respect all of that. So we will show, okay, that word will meet the design specification. So you might have a word that, okay, maybe a question of maybe saying that I don't have slack nutrition, I don't have undercourse, I don't have slack porosity. The word might be clean. Okay, no indications we need. But it's a bad word because it lacks the microstructures that we expect of it. Okay, so the word have the desirable microstructures. Okay, so it will enable that weld metal to have the desirable mechanical properties that we expect of it service. So that is the essence of welding procedure. And this bench test machine is going to make us be able to evaluate the candidate or the welder, okay, on his welding procedure performance specification compliance notions. It understands the very values, the very importance of the welding procedure specification, and duly respects. It's not a question of the welding inspector following him like a gendarme, maybe the welding supervisor following him like a gendarme. He is a knowledgeable welder, okay, who understands that no, I have to follow this procedure, okay, so much that I want to have the desirable mechanical properties. Okay, and to have these properties is because I have the desirable microstructures, and this depends on the heat input that's required. So I must put the required heat input. I don't have to weld one electrode and go and spin around. Okay, make two phone calls. Okay, they come and then come and go to the next electrode, and then go in and get another call and then go to another electrode. That is a poor word. Okay, except that the procedure accepted that in that case maybe welding some osmotic stainless steel. Okay, so we are saying that the welding procedure is very important. Okay, because the welding engineer is seeing that we establish the mechanical properties of that material across the joint during the welding operation. So we make use of the different welding processes. So the welder's ability, we're checking the welder's ability. Usually he understands the use of that welding process, okay, to deposit those the weld metals required, okay, following the welding procedure specification. So we can verify that, okay, for welder qualification, okay, the procedure for welder qualification, okay, the test piece goes to visual inspection, okay, that the welder was test coupon like this, okay. What a test coupon like this, okay, the piece is inspected visually, do visual inspection. Okay, if the piece is accepted, okay, maybe welded to maybe different codes like maybe ASME section 9 like this, okay. ASME section 9 is going to tell you the criteria, okay, that are applicable when it comes to inspection of the work of the test coupon, okay, visually. So the acceptance criteria, maybe you look at the ASME section 9, maybe 194 there, gives you the criteria of visual inspection. So the criteria there, once this piece conforms to this acceptance criteria, that is performance test coupon shall show no cracks and incomplete joint penetration, and weld metal and with complete interest of weld metal and base metal. If this criteria is met, the piece is accepted. The piece is accepted. Then you can move the piece to the next page, which is mechanical testing. That's the bench test. At that level, samples are expected from the piece. Okay, this is the coupon. We extract samples from the piece. Okay? Okay, we extract samples from the piece, okay, according to the description of the code. Okay, these samples are carefully extracted like this. Okay, for hook and face bends and side bends. So that depends on the description of the code there. So you have the root bend sample, this, okay, cannot extract it to the dimensions. For instance, you can have this 68 millimeters there, here, 8 millimeters. Then you have, that's the root bend. And then have the face, okay, and then have the side bend. Side bend, okay. So they have been extracted from the welded coupon, but take particular attention. The piece must have been accepted visually, and then move to this next stage of which we call the mechanical testing using the bend test machine. So that is where Mr. Bend test machine intervenes in the qualification process. So this machine now is very important. Okay, with the bend test machine now, okay, we can bend these samples. Okay, that's extracted from this. If the sample are analyzed, okay, that is we bend them using the bend test machine, and we don't have any indications. Okay, the indications as spelled out in the code, then the piece is accepted. So let's proceed there. So proceed our first sample there. This is the samples for side bend. Okay, we have two samples of side bend. So this sample of side bend, okay, look, dimension there, okay, are supposed to be 10 millimeters. 10 millimeters. Yeah. So put it there. So the machine will be carefully designed. Okay, put it there. Carefully designed. Okay, accept just 10 millimeters. Okay, 10 millimeters. No problem. Okay, so put it there. You go through. About 10 meters, you will not move it. Okay, about 10 meters, you will. The word is at the center. The word is at the center there. Okay, so this is the first. Okay, this is the first pipe. Check the map very well. Okay, so we have equal place at the center. Okay, and then we proceed. Okay, there we have it on police. Okay,
Police. Okay, busy.
okay, that sample fails. That's the sample. It failed. Here, another sample. So you see these are the bent test samples. Okay, we'll bend them. Okay, using our bend test. After the bend test, the next thing is to do inspection. Okay, if you look at this sample fails the side test. The side test fails. Okay. But then you have to measure it. Okay. Okay, look at this. The face bend. Okay, the face bend. Okay. Normally, you look at it. Okay, and do proper inspection. Okay. And make sure that, because according to the code, okay, we have the acceptance criteria. Okay. So look at the indications that are visible. No visible indication should be more than 3 millimeters. So, as we have seen, those are the test samples. Okay, this tells us that what's the problem? This welder has this problem. Okay, 2 of these test samples. Okay. Even the visual inspection of the test report was not accepted. You see there? So, you see there? Okay. So, if we didn't have this, okay, right. So guys, what are we saying here? As welders, the use of the welding procedures following the execution of the welding procedure is for the execution of the weld. Because that weld is supposed to have the desirable mechanical properties, and those desirable mechanical properties are dependent on the microstructures that are present in the deposited weld metal. And that is the very essence, the very problem the welding engineer has. You see that those mechanical properties of the base metal, are re-established across the joint during the welding process. And that, okay, the welding process is established, heat input control. That so much that you, as the welder, you should follow it so much that you have good words. See the guys? So that is on the benefit. So we proceed to the which means this has failed. More heat input. You want to put electric go out there, spin around, come in, go around electric, go around, spin around, come on, go around electric.
That's why
yes. Low, the heat input is not adequate. Like just like okay, your shield casting, okay, that is glass out of person. So you have to respect the heat input. You know once there's an amount of heat that is required to a drawing, you make sure that you respect that amount of heat. You see me there? If you don't respect the amount of heat, what you are doing there is just nonsense.
Absolutely.
That's what I'm saying there, guys. Yes. That is the very essence of welding. Okay? Welding is not just an art. Okay, that is what you want welding to be shiny. Okay, shiny like this. It is both an art, a science, okay, and it involves technology. It's applicable there. You see that? So okay, if you let your welding to be shiny, okay, you miss the point. Because you just go out there, weld and come back and weld. Your end result is like, okay, I want it to be shiny. No. You have properties that you're looking for, okay, and those properties must be present in the base metal for you, in the welded deposit weld metal, for us to understand that this is good well. Get it there, guys? For welder qualification, okay, and qualification of welding procedures. So if a welder who is qualified using the bend test is a good guy. He's a good guy. He knows that guy is a knowledgeable guy. He knows so many things. He has so many things in his head.
Yes, sir. So another can see past the radio and see through the bend test.
That is what I'm saying. Radiography is just going to. Radiography is what radiography does. It just checks if you have any dirt. I'm calling it dirt. What do you call the indication? Okay. If you have any slack inclusions, lack of fusion, or maybe a porosity in there, if there's nothing like that, okay, it's accepted. No undercourse, no undercourse here. It's accepted. But it doesn't tell you if the microstructures are the adequate microstructures that are required. And that is only possible. You can only be sure of that. If you want to test it and be sure of it, that the microstructures are okay, use the bend test. okay, that is the welder respected that welding procedure. The heat input was right in graduate service data. That is a knowledgeable guy. You understand? I'm not just welding this stuff. That's why you see on many some projects that done okay, and then before they get into services, maybe the project was maybe the last 5 years, 2 years, and so this program already. You maybe find the structural components developing cracks all over. Why? Because the processes were not respected. The welders, maybe some of the inspectors maybe just rely on the radiography. Okay, maybe the ultrasonics. But if they did not have those guys who are knowledgeable, that problem will have problem. Sorry, that project will have problem in the nearest future. They will not see that then. If just maybe to 2 years, oh, you see that it's collapsing. What's happening? But you did all the engineering right. What is happening? Is it magic? It's not magic. Those guys do not respect the welding procedures. That is what we is stamping out. We stand against.